So, what we're going to be doing is going over the review sheet today. We'll go over half of it today, the other half tomorrow. So the video will be up there. And I did write a note to Mr. Hendren to let you all use the Chromebooks to be able to get on there and watch the video. Okay? So, not yet.
Oh, is he retired?
Possibly. Now, our direct variation equations come in the form of y equals a times x or x equals a times y. We also have the form of a is equal to x over y and a is equal to y over x. So direct variation can come in one of these forms, these four forms. Inverse. Y is equal to a over x, or x is equal to a over y. And the only other way we can have an inverse equation is a is equal to x times y. Only three that we can have. Now, one of the giveaways of it being either one of these is addition or subtraction. So number 3 is neither because it has addition. So for these first 6, if there's addition or subtraction at all in the equation, it is neither. Well, that makes one of the other ones kind of a dead giveaway, which is 6. It is neither. Because, again, we have addition. Addition or subtraction sign at all. When we're determining direct or inverse variation, it is automatically neither. Questions on 1 through 6 so far? We good with this here so far? Yes? Okay. You good? Okay. Now, before we jump into 1, 2, 4, and 5, I'm going to write an additional one down here. What would this one be? Y equals 7 over 5. So that's not on there. Direct, inverse, or neither? It's not direct. It is. And there's a specific reason why.
It's irrational. It's an improper fraction. What is it when 7 over 5 is?
That's an improper fraction. How about, what is it missing that the others have? An x. It only has one variable, yes? We never did cover this or kind of state it outright, but if we're talking about direct and inverse variation, we've got to have an x and a y. We have to have 2 variables. If we only have one variable, it's automatically neither. We're not comparing anything. So really, if it only has one variable, or our addition or subtraction, it's automatically neither. All right, let's look at number 1. 8y equals x. Would this be direct, inverse, or neither? So match it up to the equations. 8a is just our number. It would be direct. Yeah, direct. Number 2, x times y equals 1/5.
That is
Inverse, because our x times y equals a. Number 2 would be inverse, because that matches up to our x times y equals a. Which one? Yeah. Yeah. And this would be inverse. Y is equal to a over x. X is equal to a over y. or a is equal to x times y. And a, again, I didn't state this earlier, a is just a number. So a is standing for the place of any number, fraction, whole number, any of them. Yeah. So here, a is just a constant term. So for number 2, a is 1/5. So it's just taking its place. Number 4, 6 over x equals y is inverse. So we match it up to the form that we have. If a variable is on bottom by itself and the other variable is on the other side, we're talking inverse. Number 5 is inverse also. Questions on 1 through 6? Huh? Possibly. We good with 1 through 6? We ready for 7 through 9? Well, they're not on the test, so we're not going to look at them. Number 10, 2x squared over 3x squared minus 4x. Whenever we're simplifying, we need to factor everything on top and bottom as far as it'll possibly factor, and then simplify from there. So if we look at the numerator, 2x squared, how will it factor?
It's a perfect square. Is it not?
It wouldn't be a difference of perfect squares. Well, will it factor?
Yeah, excellent.
How many terms do we have? 1. So it is just 2x squared.
Oh, that's it.
Yeah.
I mean, it's so much.
Because we could break it up to x and x, but single term, it's not factoring. 3x squared minus 4x. We should always be looking for what first? Greatest common factor. Is there a greatest common factor between 3x squared and 4x?
No, x.
X. We can factor it out. And when we factor it from 3x squared, we have 3x. And we factor it from our 4x, we have 4. Now 3x minus 4 doesn't factor any further because no powers other than 1. And we have this here. Now is there anything in common on top and bottom? X and our x squared. And that would reduce, and our 1x is gone on bottom. And we only have 1 left on top, leaving us with 2x over 3x minus 4. That's it. Questions on this here? Questions on any of this so far? Let's look at the next one, number 11. Again, first thing we should be looking for is the greatest common factor. Is there a greatest common factor in the numerator? What? 32x squared has an x. Does 50 have an x? No, but there is a greatest common factor between these two numbers. What goes into both 32 and 50? Not 4. So 2 goes into 50 and 32.
Oh, it does. Sorry about that.
And when we factor it out, 32 divided by 2 gives us 16. 15 divided by 2 gives us 25. Is there a greatest common factor between 4x squared, negative 17x, and 50? No. Now we can factor this. 2 sets of parentheses with 3 spaces. Since our third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of 4x squared. X and x. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. Factors of 15 are 1 and 15 or 3 and 5. Which one do we want to try first? 1 and 15 or 3 and 5? 3 and 5. And we can check this here. 4x times negative 5 is negative 20x. Negative 3 times x is negative 3x, giving us negative 23x. Well, before we change any numbers, we can switch to 3 and 5. Switch it and try this again. 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, giving us negative 17x. That is the middle term we wanted.
Oh, I thought you needed a 16.
Luckily, 16 wouldn't be the middle term. If it was, it wouldn't be factorable, most likely. Yes. Now, the denominator for the next part will still be the same, our 4x minus 5 and x minus 3. Because that's already factored, so we don't need to do anything else to it. But we still need to factor the 16x squared minus 25. And it is difference of perfect squares. Question. Okay. Yes. So if we look at the two terms, they're being subtracted, yes? No middle term. 16x squared, what times itself is 16? 4. What times itself is 25? 5. So 16 and 25 are both perfect squares, and it's a subtraction, so we're saying it is a difference. Difference of two squares, difference of perfect squares. And since it is a difference of perfect squares, the signs are going to be opposite. Factors of 16x squared are 4x and 4x. And our 25 is 5 and 5. Yes. Huh? Yes. Welcome. Wrote the wrong factors. The one on top? Yeah. Now, if this 16x squared and we had, say, plus 25, then we would be done. But since it's minus difference of perfect squares, it is factorable. 3? Yeah. It's not a nice looking. Yes. It's a 3. There we go. Now, do we have something in common on top and bottom?
Yeah.
4x minus 5, yes? They would cancel, leaving us with 2 times 4x plus 5 over x minus 3. And that's it. Now, for the simplifying part of the test, I make sure that everyone will simplify, every single one of the problems will simplify in at least one way. So either, like on the first one, a common factor of x on top and bottom will simplify. There's going to be something that simplifies. It's not like one of the ones on the homework where it just didn't simplify at all. There will be some way to simplify them. Questions on either of these two here? Yes.
Do we need a list of restrictions?
No. Thank you for bringing that up. I removed that from the test because it's not difficult. It's a little bit unnecessary, and it's just taking up extra time. So I'm not worried about it. The only time we'll need to focus on the restrictions is when they come up for our solving. Yeah. The solving, yes, but they're not going to take up as long as some of the ones that we had. There is one of the ones with solving that takes not more than 3 steps. It actually simplifies really quickly, really nicely. 12 and 13. I did 12 on the full video. I'm not going to do it on this one here because difference of 2 cubes is not going to come up on the test. X cubed minus 27 is a difference of 2 cubes. It's not going to come up on the test. So I'm not going to focus on it. However, we can have something like 13, x squared minus 4x minus 12 over x squared minus 4. X squared minus 4 is a difference of 2 squares, difference of perfect squares. Because x squared is x and x, 4 is 2 and 2. So this would factor 2, x plus 2 and x minus 2. Now the numerator doesn't have a greatest common factor. The denominator didn't either. But we can factor this here. Since the third term is negative, our signs are opposite. Only factors of x squared are x and x. Factors of 12. 1 and 12, 2 and 6, 3 and 4, yes? Which one do we want? 2 and 6. And part of the reason we want 2 and 6 is because if something's going to simplify, we either need x plus 2 or x minus 2. Where do we want to put the 2 and where do we want to put the 6? 2 on plus, 6 on minus. And if we do check this, x times negative 6 would be negative 6x. 2 times x is plus 2x, giving us negative 4x, which is the middle term we wanted. And that is nice because what's in common? X plus 2 and x plus 2, leaving us with x minus 6 over x minus 2. And that's it. Yes.
So on the test, are you going to give us 2 days or you just give us 1 test?
I'll probably give you 2, but you should be able to get it done in 1. So I would try to get it done in 1. That way you're not having to worry about it across 2 days. Questions on this here? You feel comfortable with this? Yes? No? $14 through $25, perform the following operations. Again, we don't have to worry about restrictions. 14, a problem like 14 is not going to be on the test. Checking the time. 2:49. Now, we're not going to have monomials, but we will have problems like 15 where we are going to have to factor expressions. So problem like 14 where we have a single term on top and bottom for everything, not going to show up. So we'll have to do some factoring. Now, here, x minus 1 and 2x are already factored as far as they'll possibly go. They're simplified. The numerators, x squared minus 4x and x squared plus 3x minus 4 have to be factored. We can do the x squared minus 4x first. How can we factor it? Well, we don't have a term without x, yes? So they have a greatest common factor of x. Which gives us x times x minus 4. because again, I normally have a tendency of glossing over it, but if there is a greatest common factor, we need to take it out first. Because our other one, x squared plus 3x minus 4, there is no greatest common factor between it, number or variable. So that's when we move on to our two sets of parentheses, because it is factorable. Since our third term is negative, our signs are opposite, plus and minus. Only factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to use? 1 and 4. Do we want the 4 positive or negative? 4 is positive, 1's negative. Because if the 1's negative, we now have an x minus 1 on top and bottom, and it will reduce. And x plus 4 times x minus 1 is the correct set of factors. Now, if we multiply this together, the denominator would be 2x times our x minus 1, because that is one term. The numerator would be x times x minus 4 times x plus 4 times x minus 1. And our x minus 1's will cancel. Will anything else cancel? There's one other thing.
The x and x.
Yeah, the x and x will cancel out, leaving us with 2 on bottom, and the top is x minus 4 and x plus 4. If the numerator simplifies out completely, we have to leave it as 1. If the denominator simplifies out completely, we don't have to rewrite it as 1. Question on this one here. Now, if everything simplifies out, it just reduces to 1. Reduces to 1. You ready for number 16? If it's already factored, if we already have two sets of parentheses, don't multiply it out, because again, the first step with the multiplication and division is to factor it. With addition and subtraction, we have to factor the denominator. If it's already factored, leave it alone. We don't have to do anything to it. Now, out of this one here, do any of the expressions 16 have a greatest common factor? Okay.
X.
4. Yeah. On one of them, the numerator of our second does have an x in common with 2x squared and 4x. Yes. Anything else? 2. Because we can take 2 out of 2x and get x. And if we take 2x out of 4x, we're left with 2. And most likely that's going to be helpful because we're hoping one of the denominators has x plus 2 as a factor. Where do we want to factor next? Doesn't really matter, we got to pick one. Top. X squared plus 3x minus 4. No greatest common factor. We do have 3 terms, so 2 sets of parentheses. Since our third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. 4 and 1. Which one's positive, which one's negative? 4 is positive, 1's negative. If we check this, x times negative 1 would be negative x. 4 times x would be positive 4x, giving us our middle term of 3x. One of the things we know, it probably wouldn't be 2 and 2, because that would make it a difference of perfect squares. X plus 2, x minus 2. All right. We can move to the denominator, x squared plus 4x plus 4. Since the third term is positive, our signs are the same and match the sign of the middle term. Only factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. What do we want? 2 and 2. And if we do check this here, x times 2 is 2x. 2 times x is positive 2x, giving us our 4x. Now we do have something in common on top and bottom now. Yes, our x plus 2 and x plus 2. We can simplify that in a minute. But it brings us to our last one, x squared minus 4x plus 3. Since our third term is positive, the signs are the same and match the sign of the middle term, minus and minus. Factors of x squared are, well, x and x. Which factors of 3 do we want? Well, there's only 1 and 3, yes. You're good. 1 and 3 is only factors of 3. I kind of asked a misleading question. Now at this point here, we need to multiply everything together, yes? And when we multiply together, we're really just merging the numerator and numerator terms, put them next to each other. The denominators, we're doing the same thing. So what's in common on top and bottom? X minus 1 and x minus 1. X plus 2 and x plus 2. And what that leaves us with is 2x times x plus 4. And on bottom we have x plus 2 and x minus 3. And that's it. Questions on this here? $17. The second expression doesn't have a denominator, but it's understood to be 1. And out of the 3 other expressions, well, none of the other expressions have a greatest common factor. So we're not factoring it out. But x squared minus 16 is a difference of perfect squares because we have 2 things being subtracted. X squared is a perfect square. It is x and x. 16 is 4 and 4, and our signs are positive and negative. All right, now our x squared minus x minus 12, if we factor it, since 12 is negative, our signs are opposite. Only factors of x squared are x and x. Now our factors of 12 are 1 and 12, 2 and 6, 3 and 4. Well, to have something in common, we're going to have to use 3 and 4. And just moving us along, it's going to be x plus 3 and x minus 4. Now this is nice because, well, we already have something in common on top and bottom, and it's all in the same fraction, so we can go on and get rid of it. X minus 4 over x minus 4 simplifies. Should have wrote that one in earlier. Leaves us with the last one, x squared plus 2x plus, or not plus, x squared plus 2x minus 8. Since the third term is negative, our signs are opposite. Factors of x squared are only x and x. Factors of 8 are 1 and 8 or 2 and 4. Now the only thing we have left on bottom is x plus 4, yes? So if it's going to simplify, we need the 4 positive and the 2 negative. And if we check this, this actually does work out. Multiply them together. And the only thing we have left in common on top and bottom is x plus 4. And what that leaves us with is x plus 3 times x minus 2. Now, since the denominator simplified out, we don't have to rewrite it as mean over 1. But if the numerator had simplified out, we do have to write it in as 1. Questions on this here? Luckily, the lid was still on that. Questions on any of this here? Next thing we're going to look at is division. Now, 18, just like the one before, is not going to, one just like it is not going to be on the test. We're going to have something more like 19. Now, whenever we divide two rational expressions, we do what? Keep, change, flip. We keep the first one the same. We change it from division to multiplication and flip our second expression. Keep, change, flip. Okay, good. Yeah. Here. Oh, thank you. Yeah. I don't know why I wrote a 3. Now we just need to factor. So I'm going to start off. It doesn't really matter where you start factoring this. We just need to pick one and go from there. So I'm going to start off with x squared minus 3x minus 40. Since the third term is negative, our signs are opposite. The only factors of x squared are x and x. Our factors of 40 are, well, 1 and 40, 2 and 20, 4 and 10, 5 and 8. And it actually works out that it's 5 and 8. Now our denominator, since the third term is negative, our signs are opposite. Only factors of x squared are x and x. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. Now it'd be tempting to do 2 and 10, or not 2 and 10, 4 and 5, but they don't give us the correct middle term. 2 and 10 is what we need to get that 8x. So nothing simplified on that first rational expression. But when we move over to the other numerator, our x squared plus 12x plus 20, since the third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And the factors of 20 that we want are 2 and 10. Now doing that, we do get something in common on top and bottom this time. Now we need to factor the last one, x squared plus 13x plus 40. Since the third term is positive, our signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x. And then we would have 5 and 8. Multiply them together. What's in common? X plus 5 is gone. Anything else? X plus 10. Which leaves us with x minus 8 times x plus 2 over x minus 2 times x plus 8. So it's very tempting to try to cancel everything else out, but because the signs are different on the last ones, we can't just cross them out. Now, if it had been x plus 2 or x minus 2 and x plus 8 on top, then it would all simplify out to 1. Questions on this here? Okay. I'm going to try to get through these last two here before we call it a day. Luckily, these two here are nice because whenever we add or subtract, we need the denominators to be the same. Well, with 40, the denominators are already the same. It doesn't matter how they look. If they're the same, we can go on and add or subtract the numerators. Now here, even though we're subtracting, we don't need the sets of parentheses around it because it's just one term on each. Because we've applied that negative to everything in the second set of second expression, so we don't have to do anything to it there. Four x squared minus 1 is factorable. It's a difference of perfect squares. Because 4x squared, well, that's 2x and 2x. Signs are opposite, and well, 1 times 1 is 1. Do we have something in common on top and bottom? 2x minus 1 and 2x minus 1, leaving us with 2x plus 1. If the denominators are the same, we can go on and add or subtract the numerators. Doesn't matter what the denominators is. If it's just a single expression or two sets of parentheses that are the exact same under each fraction. If they're already the same, we can add and subtract our numerators. Here, they're all 3x plus 2, so we can add the numerators together. It's going to be 3x plus 2 on bottom. The numerators, 9x squared does not have any like terms. But our 6x and 6x give us plus 12x. Negative 1 plus 5 is plus 4. Now, since we're really running short on time, I'm going to tell you that the two factor to 3x plus 2 and 3x plus 2. Because I think at this point, we feel pretty comfortable with factoring. So getting to this here, and the 3x plus 2 and 3x plus 2 would cancel, leaving us with one single 3x plus 2 on top. Well, we would need another 3x plus 2 on bottom. Because only one of them cancels on top and bottom, so we're left with a single one on top. And that is, yeah, we'll pick